Greetings, friends! Today we will be programming a propeller to turn either clockwise or counterclockwise with pauses in between, followed by a Fantasia of flashing LEDs. Alright, so let us begin. So we're going to assume that you already have the correct wiring on your circuit board, so our focus will solely be based on the programming for today. So the first step is to set up a frame of two flat sequences. In the first sequence, we will have the program for the propeller's loops, and in the second sequence, we will have the program for the cavalcade of lights. So basically, how flat sequences work is that they will follow the programs given in a sequential fashion from left to right. So the second step is to set up a for loop within the first frame of the flat sequence. The for loop will allow the program within it to loop a certain amount of times until it has to move to the next frame in the sequence. So the third step is to set up a case structure within the for loop. Within this case structure, we will have all the commands that we need to execute for the propellers and LEDs to function in the way that we want them to. So right now, we are focused on having the propeller turn clockwise while the right LED is on for 5 seconds, have both of them off for 2 seconds, then turn counterclockwise while the left LED is on for 5 seconds once again. And keep in mind that in both sequences, only one LED is on, either the right or the left.
As it is right now, this case structure only has two cases, true or false, but we need 5 cases to follow the commands we want, 1, 2, 3, 4, 5 respectively. So the first stage is going to be everything is off. Everything is controlled by the switch. The second stage is the propeller turns clockwise, right LED turns on, left LED turns off for 5 seconds. The third stage is going to be the propeller and LEDs are off for 2 seconds. Fourth stage, the propeller turns counterclockwise. Right LED is off, left LED is on for 5 seconds. The fifth stage is the propeller and LED are both off for 2 seconds. Alright, so we will now add Emu constants with 5 values. 0, first stage, 1, second stage, 2, third stage, 3, fourth stage, and 4, fifth stage. Also, since we want the program to operate on the click of a button, we need to have the case in which everything is off, which is EMU value 0. As it is right now, there are no values assigned to the EMU constants. In order to give these constants values, we must first right-click it, then click Edit Items, and then start inserting your values. Feel free to give them names such as off, forward, pause 1, reverse, and pause 2 for ease of understanding. So now that these EMU constants have values, we can run a connection from the EMU constant to the frame of the case structure and have it connect to the green question box. In order to add each of these values in each case, we will right-click the case structure and click Add Case for each structure.
Now that we have a case for each of the 5 values, we can now copy and paste the enum constants into each of the cases. The function of these enum constants will be to guide the program in the sense that it tells the program where to go after each case. For example, in the first stage, 0, we can set the enum constant to the second stage, 1, which means after the first stage has been executed, it will move to the next stage and so forth. Once we reach the 5th stage, it will move to the second stage and the program will continue forward until we tell it to end. The reason as to why we don't want it to go to the very first stage is because of the fact that the first stage is the case in which everything is off. Also, now that we have the constants in each case, we need to wire it from one end of the case structure to the other. When you see the box with an arrow pointing to the left, right-click it and click Create Constant and make sure it's set to value 0, stage 1. We need to do this because this will be the default stage in which the program will go to when it runs. We want it off initially. Alright, so now that we have each stage set up, we can start adding Dac Assistants to each case. The Dac Assistants are the things that take the code from the PC and translate it into something that the LEDs and propellers can read. There will be 4 Dac Assistants that we will be using for the left LED and the right LED, the motor, and the switch. 3 of these Dac Assistants will be in the case structure, the 2 LEDs and the motor, and the other Dac Assistant will be in the while loop within the first case structure. The Dac Assistant in the while loop will control whether the program is on or off. Basically, the while loop states, while the button is switched into a high state, the program will operate. So to insert a Dac Assistant, we have to right-click on the block diagram, click Express, and in this case, we want to select Input because the switch controls the operation of this program. Then be sure to click Dac Assistant.
For the ninth step, we must wait for it to initialize. Once it is finished, you should be able to see a tab with two options, acquire signal or generate signal. In this case, we would want the switch to acquire the signal from the MyStem board and have two states for the program, high or low. From there we want to select digital output, then select port/line output, and select whatever line you have your switch connected to. Also, be sure to check the box invert line because you want it to be in a low state when it isn't pressed, and you want the switch to stay in a high state when it is pressed. Once you're comfortable with how things are, click OK and the Dac Assistant will build. Now that the Dac Assistant has been built, place it within the while loop. Place an index array that has a connection running from the element port to the stop button. Make sure that the Dac Assistant is connected to the array port. For the next step, run a connection from the while loop to the actual case structure. With the while loop in place, we can now go forth with adding Dac Assistants to each case. Let us begin in the first stage. Value 0 with a Dac Assistant from the motor. We will do the same thing, but instead of the switch being an input, it will be an output. These outputs will be obtaining the command from the switch. We will now place it in. Click Generate Signal, Digital Output, Line-Port, and click whatever you have the motor hooked up to. We want it to generate a signal based on what state is provided by the switch. We can now run a test to see whether the wiring is correct or not. If you are satisfied with what you have, press OK and you're good to go.
Now, for the programming of the two LEDs, all you need to do is repeat the process that you took in step 12 with programming the motor. Now that we have our Dac Assistants laid out, we will now have false constants connected to these Dac Assistant outputs. We're in the initial case where everything is off, so we want the constants to remain false. To place a false constant, right-click the block diagram, click the Boolean box, select the false constant, and place it in. With the false constant in place, we must now add a build array in order for the Dac Assistants to read the constants. For the motor, we will need to make sure that we have two false constants, and we need to extend the build array to accommodate two more. We will explain why we need two constants for the motor later on. Now that we have finished setting up the initial case, we can now move on to the next case, which controls the clockwise motion of the motor. We can copy and paste the Dac Assistant from the initial case to here. Instead of false constants, we would like to connect true constants to these Dac Assistants, except for the left LED. Since we want it to run for a certain amount of time, we would also like to add a timer. In order to do this, right-click on the block diagram, click on Timing, and paste the wait block. Afterwards, right-click on the block diagram, click on Numeric, and add in a numeric constant with a value of 5,000. We're setting it to 5,000 because everything here is read in milliseconds, so 5,000 seconds basically mean 5 seconds. And also, make sure that both of the constants are true for the propeller.
Now we can move on to the next case, which is to make sure everything is off for 3 seconds. In this case, we paste the DAX and make sure every constant is false. We also have to add a timer once again, but this time we make sure that the value is 2,002 seconds. For the next step, the case will be similar to the clockwise case. In order to make sure the turn is counterclockwise, we make sure that the one constant is true and the other is false. Also, the left LED is true and the right LED is false. And remember to wait for the timer's value to be still at 5,000, 5 seconds. Now that we have the general sequence for these outputs, we can add a value in for the loop in order to make it run for a certain number of times. We want this to run for 9 times, in a total of 2 loops plus the initial off case.
Alright, so we are now finished the clockwise counterclockwise motion of the propeller. We will now be moving on to the Fantasia of dancing lights. To get started, right-click the right side of the flat sequence and click Add Frame After. Once for the first program and the first frame has been completed, it will be moving to the case beside it, to the right. Our Fantasia of dancing lights will consist of LEDs flashing back and forth. Each will be on for 3 seconds. To begin, we must add another for loop to the first flat sequence, similar to the first sequence. We will then place another case structure and do the same thing that we did in the sequence prior to this one. The only difference is that we will only have 2 Emu Constants, 0 where the first stage, right LED on, left LED off, and 1 or second stage, right LED off, left LED on. Again, you can rename these constants in order to understand things in an easier way. Once you have your enum constants laid out, wire the terminals and constants in the same way they wired on the previous sequence.
Now it's just a matter of copy and paste. Copy the DAC assistants for the LEDs and paste them into their corresponding case structure. The propeller is not in any of these cases as we want it to remain turned off. We also want to set the time to be 3000 ms or 3 seconds. We want this to go through 4 runs, which equates to 2 loops. To do this, we must add a numeric constant of 4 to the n value of the for loop. Now that this is done, we can add another frame afterwards in which the lights are both on for 5 seconds or 5000 milliseconds, and then they turn off. This is the conclusion to our program.